Alright guys, today, sorry, I just got choked up a little bit. Today we're going to talk about what's called experimental probability. So we're going to continue talking about what we already know about probability and continue our unit a little bit further. So we've already talked about theoretical probability, and when we're talking about theoretical probability, that's what should happen. So what should happen based on theory. Okay? But of course, if it's a theory, it doesn't mean it's actually true. Experimental, well, think about if you have an experiment in science or you're looking through something and trying it out and you see the end result. So when experimental probability is what actually happens. So these are your actual results. What actually happens. The results. So for example, we've talked about, okay, theoretical probability, an example for that is if you had a 1 out of 6 chance of rolling a 3. And we could say in theory, okay, if you rolled that die or that cube 5 times, how many times would you roll on that 3 and land on there? But the experimental probability is what actually happens. So the experiment itself. So let's look. So the spinner with 3 equal sections is spun 60 times. Again, it has to be 3 equal parts, okay? And it's spun 60 times. So what is the experimental probability? So what was the probability of spinning green? Well, right here, we have 21 green out of 60 spins. The probability of blue, right here, is 15 out of 60. And then the probability of red was 24 out of 60. So our numerator is still the favorable outcomes, but this is the green results out of the total results. This represents the blue results in my bar graph over there to the total results. Then the 24 represents the red results from that spinner out of the total results. Okay? So if you stop and think about it, in theory, the probability of spinning a green, well, that's 1 color out of 3 sections. So we would have written 1 out of 3 if they asked me theoretically. If they asked theoretically what are the chances of landing on blue, that would have also been 1 out of 3. If they asked for red, it would also have been 1 out of 3 because that's 1 out of 3 parts for each of these. But if they're asking for experimental probability, that's based on the actual results that you get. Okay, so that's what we're going to use our information. Okay, another thing to think about, well, 21 plus 15 plus 24, 5 plus 4 is 9, plus 1 is 10, 2, 3, 4, 5, 6. There's your total of 60. And that makes sense because when we talked about probability and its complement, the likelihood of something happening plus the likelihood of something not happening, that covers all your results. So 21 60ths plus 15 60ths plus 24 60ths would give you 60 out of 60. That covers all your 60 results. Okay? So you need to be very careful when you're reading a question because, again, if they ask what's the theoretical probability of spinning and landing on blue, we would say 1 out of 3. But if they said using the results, what's the experimental probability or what was your result, it's 15 out of 60. Okay? Again, with probability, we can reduce, but we're just going to leave those like that for just right now. Okay? So now we can also use this to make a prediction. So it says, based on the results of the experiment, how many times are you likely to land on green if you spin the spinner 80 times? So again, our favorable outcome is the numerator, our total outcomes is the denominator. And what we're looking for is landing on green. So I'm going to say land on green to total outcomes. So this is your probability. And in this situation, this is actually going to be your experimental probability. So I change this around. Experimental. When we've looked at that in our previous lessons, this was our probability in theory, but right now, we actually already know the results. So we're not going to write 1 out of 3 because it says based on the results. So as soon as you see based on the results, that means this original ratio right here is going to be the experimental probability. So landing on green, we had a 21 out of 60 chances that we landed on green. Okay? Then they want to know about spinning 80 times. So I'm going to put 80 here and my x like that. Now here again, you can cross multiply and divide on every proportion. But look at those numbers. 21 times 80 divided by 60, those are really big numbers. So what I would suggest, well, 60 to 80 we can't multiply or divide. 60 to 21 we can't multiply or divide to get there either. So we don't have a factor of change or a scale factor just yet. But what we could do is we can actually reduce. You can always reduce that first ratio. So if we have 21 out of 60, we can say, well, 21 and 60 can both be divided by 3. So 21 divided by 3 is 7. 60 divided by 3 is 20. We're not changing the value of that fraction, but what we're doing is just rewriting it so that way we can have a little bit smaller numbers. So 7 out of 20 is equivalent to 21 out of 60. So already these are going to be easier numbers because 7 times 80 divided by 20, that's already a lot smaller numbers to work with. But here again, now we can see, well, 20 times 4 is 80. So we have a scale factor of 4. And 7 times 4 is 28. Okay? If you don't see it that way, you could have done it the original 21 times 80, or even this way, 7 times 80, and divide by this new number, which was 20. We'll still get 28, and I'll show that to you. Okay? So again, I'm just trying to show you multiple ways. So let's take it back to the original. This was 21 times 80, and my original denominator was 60. Check it out. You still get 28. Even if you reduced and didn't find that scale factor, if you kept this as 7, 7 times 80, move that over again, divided by, now we have a 20 down there. See how you still get 28? So no matter what, I'm showing you a couple different results that mathematically make sense. So we're going to see that x equals 28. But what does that 28 represent? 28 times to land on green out of 80 total spins. So the question, how many times are you likely to land on green? You are likely to land on green 28 times out of 80 spins. Again, this is just a prediction. It's a prediction based on the experiment, but that doesn't mean it necessarily is going to happen. Okay? Alright, let's keep going. We have a couple more. So if we have a survey and we have our results, and it says a survey was given to 70 zoo visitors. They were asked to name their favorite animal exhibit. What is the experimental probability? So that means the results, based on the results, key phrase right there, that a visitor will choose the penguins as their favorite exhibit. So we're looking for the probability of the penguins. Okay? Now normally, if this was theoretically, what should happen, well, we have 1, 2, 3, 4, 5 animals. So we'd say there's a 1 out of 5 chance of them picking penguins. But if it's based on the results, that's actually based on what people said. Okay? So let's start with the beginning. Our original ratio is going to be our experimental probability. So we're going to compare the penguins to the total. So here's our penguins. And so what we did on this, we had a tally. So as people were coming in, they were tallying them up. So they give them a mark. And they do these Roman numerals. So that's 5, 10, plus 3 more is 13. So there's 13 out of, well, a lot of people want to go, okay, 70, I see that number. Don't necessarily think of it that way though. We have to total them up. This is based on, this is what I'm getting to. That's my prediction. So look at the data itself. You have 13 out of how many? So if they don't give you the total, we're going to add that up. So 6 plus 17 plus 21 plus 13 plus 13. So 3 plus 3 is 6, 7. 7 plus 7 is 14, plus 6 is 20. 2, 3, 4, 5, 6, 7. So it ended up being that 70. So sometimes they might not give you that number. So it looks like they did on that one. So there's 13 out of 70 chose penguin. So this 13 represent the people who choose penguins as their favorite to the 70 total visitors. So that is based on the experiment itself. So now it says, suppose 540 people visit the zoo. Predict how many people will choose the monkey exhibit as their favorite. So we're going to use our proportion table again. So I'm going to say in words, original ratio, new ratio. But now they switch to talk about the monkey. So we're not going to use this ratio. That represents the probability of picking a penguin. So in words, we're talking about the people who picked the monkey to the total. So monkey, I'll say chosen, compared to the total visitors. So my original ratio is based on the experiment. Okay, so the monkeys we have is 21. Just set up everything right there. So there's 21 people that chose monkeys out of 70 total. Now we're saying suppose, and that keyword predict, 540 people. Well, it doesn't say 540 people chose the monkey. They're saying that that's how many visitors there were. And here's the keywords choose the monkey right here. That's my X. Okay? Here again, these are large numbers, so you could cross multiply and divide 21 times 540 and then divide by 70, or think about a scale factor of change, so 70 times how much would get to 540, not really sure. 70 to get to 21 by multiplying and dividing, I'm not really sure, but look at that ratio. 21 and 70 can both be divided by 7. So if I say divide by 7, reduce that original ratio, 21 divided by 7 is 3, 70 divided by 7 is 10. That actually makes it a lot easier to either go 3 times 540 and then divide by 10, or hopefully you see, well, 10 times 54 will get you to 540. So all those strategies coming back from when we talked about proportions, not only this year, but also in 6th grade as well, helps you out. So 54 times 3. 4 times 3 is 12. 5 times 3 is 15. Plus 1 is 6. So, plus 1 is 16. So it's 162. So we're going to say how many people will choose. We can say, I predict that 162 will choose monkey as their favorite exhibit. Doesn't mean that that's going to be the exact number, but that's why it's called a prediction. Okay? Here again, if you're not seeing that well, you can do the math as well. But our original numerator is 21 times 540, and then divided by that original denominator 70, we're still going to get that same number. Okay? So just be mindful that you do have to work these out without a calculator, so that's why I'm reminding you of these strategies of reducing, because that might help you so you don't have to multiply and divide with as big numbers. Okay? As always, good luck, and please let us know if you need any help.